So in this video I'll be covering problem 41, and 41 reads, a certain alarm clock ticks 4 times each second, with each tick representing half a period. The balance wheel consists of a thin rim with radius 0.55 centimeters connected to the balance shaft by thin spokes of negligible mass. The total mass of the balance wheel is 0.9 grams. A. What is the moment of inertia of the balance wheel about its shaft? Part A, we just want to use the moment of inertia equation for a thin disk, which is mr squared. And we just have to plug in what we know, which is the mass is 0.9 grams, which you multiply by 0.001 to get it in kilograms. So that will end up equaling 0.0009 kilograms. And the radius, which it says is 0.55 centimeters. But again, we want that in the standard unit, which is meters. So we multiply by 0.01 and we get 0.0055 meters. So then we just plug that into the moment of inertia equation. We'll have 0.0009 times 0.0055 squared, and that will equal 2.7 times 10 to the negative 8 kilograms times meters squared for the moment of inertia for part A. Alright, so then we'll want to keep that answer in mind for part B. And part B says, what is the torsion constant of the coil spring? So for that part, we want to use the period equation, so we can, we want to use the period equation. So again, T equals 2 pi over omega. And in this case, with a spring, omega will equal root k over I. So we'll have period equals 2 pi over root k over I. And so then we just flip that up, and we'll have this equals 2 pi times root I over k. So then we just have to plug in the values that we know. It tells us that the period is, it tells us that a certain alarm clock ticks 4 times each second, and each tick represents half a period. So that means if one tick, which equals 0.5 seconds, represents half a period, that means the period is 0.5 seconds. So we plug that into the period and get 0.5 equals 2 pi root, and we plug in this I that we know, the moment of inertia that we know, 2.7 times 10 to the negative 8 over k. So then what we'll want to do is square both sides so we can isolate k. So we square, and we have 0.25 equals 4 pi squared. times 2.7 times 10 to the negative 8 all over k. And then we'll want to multiply k up to get it isolated by itself. Multiply by k and divide by 0.25 or multiply by 4. So actually multiply by 4k, multiply by 4k over here. So we'll have k equals 16 pi squared times 2.7 times 10 to the negative 8. And then with that, we'll end up getting 4.3 times 10 to the negative 6 Newton meters per radian for the portion constant. And that's how you do part B of problem 41.